All right, so here is the work through for the Unit 2 FRQs. So the first question, this was actually a pretty simple, in my opinion, FRQ, but this is something that might actually pop up in our new world as far as for an AP exam. So basically wanted you to, part A, wanted you to draw the complete Lewis dot structure for diatomic nitrogen. So there you go. Each nitrogen has 5 valence electrons, so you would have a total of 10 valence electrons. And when you go to make sure everything's nice and balanced, you end up with a triple bond between each nitrogen and then a lone pair on each nitrogen. And that gives you your 10 valence electrons. Now, that ends up being important in parts B and C and D. So basically, the part B asks you, what is it, polar or not? Basically, N2 is not polar because the 3 bonding pairs are shared equally and each nitrogen atom has 1 non-bonding pair. Then part C, it asks you about using there's a graph with potential energy and internuclear distance, basically how far apart each of these nuclei are from each other. And it says put an X where it indicates this corresponds to bond length of N2. Well, it would actually be this one right here. That is the lowest potential energy, the most stable, and so thus it would be the longest bond length. And so that's where you would have it. Now, part D actually asks you to compare that with O2, diatomic oxygen. So if you were to draw diatomic oxygen, it would be slightly less of a negative, or the potential energy would go down slightly less, and it would have a very similar curve, but the spot would be right here. It'd be shifted over, and that's because the bond length of O2 is greater than N2 and it has more potential energy. So, and then E asks you to basically, what is the numerical quantity that is needed to convert the number of grams of hydrazine, which is N2H4, to the number of moles? Well, to convert between grams to moles, you need molar mass. And molar mass is 32.042 grams per mole for N2H4 or hydrazine. And then you go to part F, which actually shows you the hydrazine. And so you have that graph. It has nitrogen, nitrogen, and then the 4 hydrogens around it, 2 lone pairs on each. There's a lone pair on each of the nitrogens. And it says, based upon the Lewis dot structure of this, and comparing it to the Lewis structure for that, which one of them has a longer bond length between the nitrogens? Well, the answer would be the bonds between N, or nitrogen, and N2 are shorter than in N2H4 because triple bonds are shorter than single bonds. And then part F2, the bonds between nitrogens in N2 are stronger than they are in hydrazine because they are shorter. So that makes them stronger than single bonds. And then part 3, it is sp3 hybridized as far as nitrogen is concerned. And here's how I've actually included on Canvas a little cheat on how to calculate hybridization, or actually how to figure it out the quick way. But here's a really quick version of it. Here's a chart. So if you have the bonded atoms, or electron domains plus lone pairs is equal to 2, then it was sp. If that number, or that sum, is 3, then it's sp2. And if it's 4, it is sp3. So in this case, we have 1, 2, 3 bonded to each nitrogen. So there's a hydrogen, hydrogen, nitrogen, and then there's the lone pair. So that's 4 electron domains or groups, one of them being a lone pair, so that makes it sp3 hybridized. So there you go. There's the free response question from Unit 2 worked out for you. All right, talk to you later. Bye.